better to be. Otherwise, please ingest the note well again. You probably only have done it 5 times so far this week, so it's always good to take another look at it. Administrator, so for the few who may be new here to the process, please log into the Meet Echo on room tool so that you're being counted by the automatic system as being in the meeting, because otherwise we'll be having a much smaller room and maybe actually too small. So that's what the in-room tool is good for. And of course, also if you want to ask questions or so, to raise that question on the tool, then get in line. And please contribute to the meeting notes. That's collaborative editing. So that's just, you know, when you go to the notes taking from the agenda page. So that would be very helpful if you could help editing that. IETF conduct guidelines, ISG also asked to show those, right? Extend respect, courtesy, have impersonal discussions, you know, make it about the protocol sucks, not you suck. IETF participant device solutions. And then, by the way, the last line here, oh, doesn't show up. Okay, it's being cut off. Wonderful template. So sorry. Okay. Share slides meant to be very quick. We have slots for where the active work is happening, and we're just doing on the chair slide summarization of the other working group documents that don't have slots, so that we can collect and discuss necessary feedback. The working group chair slide deck actually has a lot of hopefully useful informational stuff. So if you're new to the working group, please go through all the slides. They're in the backup sections to understand more of our process details here, because we don't have enough time to repeat that every IETF, given how we only have 1 hour. Okay, so with that said, so this is here the list of our working group documents that are not mentioned, that don't have their own slots. We've got Brewski AE, which is in the RFC editor queue since September. Hooray! So that actually made it through, and hopefully we'll have an RFC maybe even this year. So I haven't checked what the RFC editor queue length is. Anything from, if there's anything out of the ordinary from the authors, let us know. Otherwise, we'll hope that that gets resolved between the RFC editor and the authors. We've got Brewski Cloud that did enter IETF and AD review after IETF 120. So I have no indication that there is anything out of the ordinary going on there. If there is, please yell out now so that the chairs can help if there is. RFC 8366 bis, no updates since IETF 120, and that's perfectly fine, because that document we think is in perfect condition, but it is depending on all the other Brewski drafts. So we mean to update and push it further down the line when the dependencies are being finished. Auto deployment, we had explained last time that we parked that for the moment. So the interesting one is actually the GRASP distribution, which I'm tentatively calling a tools victim, because it doesn't show up in the working group data tracker page as dead, which it is right now. And so we meant to push it to the AD, and then our beloved AD sent it back, but there was no notification about that anywhere on the mailing list or anywhere where the folks would have catch it up, right? So what happened?
Yeah, it was set back by our AD.
Right.
It's partly because, you know, we haven't. This was an experimental document, which is partly because we don't have enough energy to make our implementation so far. Although we still think that's good work because it actually supplements the GRASP functions, but we are slightly lack of energy, and hopefully we will talk with a vendor or carriers to find people interested in it, and then we would have a plan to make implementation, then bring back to the working group. It was between the emails between the authors and the ADs. So it led to the report to the working group mail list. That's the case.
Yeah.
I guess.
Yeah, a simple, maybe a simple draft revision with that summary in a paragraph that can be removed later might help too.
Yeah. I think maybe we can submit um, keep alive version after this meeting to say that's still in the scope and in the interesting of the working group. Right?
Okay, good. Right, so, and then we also have the constraint joint proxy, and that is also just a part of our sequentialization process. ESCO will report on the constraint voucher document, and once we feel that that's ready to, only be nitpicking or so, then we'll get back to the constraint joint proxy. And yeah, so that is pretty much what the chair slides are. The agenda is on the agenda and notes page. So any agenda bashing here? If not, then we can move on to the working group slots. And the first one would be the update on the JWS voucher from Thomas. Give me a second to bring up the slides. Go.
So hello from my side. Yeah, next slide, please. So what is the intention here? So we have RFC 8366, which specifies CMS signed JSON voucher objects. And our intention was to have JWS signed JSON. So it makes no young changes, and it is already used by Brewski PRM pledge in responder mode. Next slide. So what is the status? So the working group last call was conducted in March 2023. Shepherd write-up done in August 2023. Ready for AD review also in 2024 August, and ISG review was done in October. So you see the details there about the art review, Obsteer, and GenArt. So also IENA registration was done for the application voucher JWS plus JSON. So IENA finds it okay, and it's in the status actions needed by IENA. So what's next? We are waiting for the telechat, and if somebody is interested in doing interop testing with our implementations, we are happy to continue that. That's it.
Mahesh, so I was going back to my notes to see. Yes, I sent it for expert review, and my notes, of course, may be a little dated at this point, was that there were some comments provided. And so if you have posted an update, probably I have not seen it as yet, which I will after this meeting. So if you have addressed all the expert review comments, especially from Jim Fenton, then the next step before it goes to telechat is probably that I'll do a review of the document.
So all the remaining comments were addressed, but I'm not sure if all of your comments are in the.
No, I've not provided any comments as yet. So,
okay.
Generally, the sequence is that yes, it can follow one of two ways. One is I can send it for expert review, have the expert provide comments, have you address them before I do the review, or it can be the other way, which is I do the review and then I ask the experts to do the review. I'm trying out both the experiments, and mainly here because I want the experts to comment on it, and so that my comments will kind of incorporate whatever feedback they have in a way. So this is me just letting you know that's what I'm following as a process. to see if that works any differently or maybe slightly better. But the plan is, now that the expert reviews have provided the comments and you address them, then I will provide you my comments.
Okay. So the only issue we have, so there was an update in September, and there was another update, but here we failed the deadline. And Michael sent it afterwards by email, but I think it was not accepted in the data tracker or not pushed. So
probably because you were within the 2-week window, because my note says October 14th is when I requested for the expert review comments. So even if you tried to provide an update, the data tracker won't let you upload because you were within the 2-week window of when it cuts off any submissions. So then my notes are correct, which is once you post the update, then it'll come back to me and I'll do the AD review.
Yeah, we will do the update when the window is again open.
No, it is open.
Okay, good. Thanks.
Okay. All right. And oh, there's this other Mr. Thomas Werner that is up for the next slot.
This is why.
Yeah. I shouldn't have taken the decaf. Okay. Okay, so we're on item number 2, update on Brusky with pledge and responder mode.
Exactly. So yeah, next slide, please. So what changes do we have from version 14 to 15? So in the last IETF 120, a lightweight working group last call was requested. So the initial working group last call was already conducted in March 2023. So and this review now led to an issue in the in our GitHub repository, so number 134, so which required clarification on references, especially how Brusky discovery is used and how it is combined. So we have changes in section 6 over there, and main changes are to outline that Brusky discovery provides further approaches, but this is in another document. And so Brusky pledge in responder mode mainly relies on discovery options already defined in Brusky. Yeah. So, and yeah, what is the status here? So working group last call, as said, already done in 2023. So IoT DEAR early review done, SecDear early review done, Young Doctors early review done, Shepard review and write-up done by Matthias Kovac. Lightweight working group last call after last IETF done. And now we are in the AD review, which is ongoing phase. And also here, the request, if somebody's interested to do further interop testing, feel free, get in touch, and we are happy. That's it.
Okay. I'll try to find that.
So sorry, one correction. What I said about JWS voucher was actually slightly incorrect. It's an IETF last call. It expired, and I marked the state as revised ID needed. So once you have posted this update, that's when I'll post it for ISG telechat session. When I said that, I'm going to do the AD review, actually what I was referring to was Brusky Cloud. So sorry for that.
Okay, thank you. Good. Then thanks.
Okay. Then I think we should have ESCO.
So we're going to look at some small beers again. So these are the constrained brewski.
Was there an update in the slide, or was the Guinness already there?
This is an update, yes. So there was, I think, one beer added for Prague, and now for Dublin, another one. So okay, let's see what has changed. So we went a few versions up. So next slide. So this is a small recap. So what is constrained brewski? Well, it's basically brewski onboarding, but then for constrained IoT devices that live in constrained networks, such as 6LoWPAN, wireless mesh networks, but also other types. So the goal here is to minimize, well, a couple of things. So onboarding time and also code overhead. So we want to reduce the number of round trips that are needed to a server because the network can be quite slow. And also minimize parsing of different formats on the embedded device because it has a limited memory, where to store code. Of course, today's embedded devices have larger memories, so there are parts with like 1 megabyte or 2 megabytes or more flash for code. But this is also taken up by many other software stacks that are all fighting for space. So we still want a minimal kind of solution in terms of code size. So, and all this is achieved by making some different choices. So we move to co-op instead of HTTP and COSE signing instead of CMS signing. Okay, next slide, please. So this is the graphical version of what I just said. So you see on the right here, in left here in green, there is this mesh network. So in this case, it uses IETF 6LoWPAN terminology. So there's our routers. And there's basically one device, it's called the cBrewski Pledge. And that's a new device that is just installed and needs to onboard this network. So that's happening by contacting a local server. This is the registrar. This is still on the basically local site. The registrar in turn contacts the MASA, which is run by the vendor. So the vendor can provide approval for the onboarding. And so it provides a signed statement that the pledge is allowed to join that particular network. So that's what the pledge can do. Okay, so far the recap. So now we'll move to the next slide. To see what has been going on in the past months. So I've been working also on the cBrewski implementation. And this also has been further developed at the hackathon last weekend and also shown during the hack demo happy hour. So basically the pictures give a bit of impression what I showed there. So it's basically a simulator that simulates open thread nodes. This is an open source implementation of the thread wireless mesh networking standard. So you can place such nodes in the simulator and they will use cBrewski to bootstrap whenever they are placed in the simulator. So you can also follow the complete Wireshark traces of the actual network traffic that happens. So it's kind of simulates the complete stack all the way up to the radio. So everything is included. And that's basically an open source simulation environment that's available for this. And this is used to basically speed up the development. So you can easily run test scripts, update your code, run the whole test suite again, and see where it goes wrong without having anything to do with actual hardware. Okay, let's go to the next slide. Now,
may I ask a question?
Yeah,
So
sure.
This is,
you can do that.
so it is simulating the network, but it is running the original application code you're interested in, like your cBrewski code.
Yeah, it basically runs a complete stack, and the stack includes the cBrewski code, and it also runs application code that one can put on top of the stack. So it's basically a C or C++ application that gets all compiled into one unit, basically to Linux. Normally it goes into the embedded device, but it's now compiled for Linux. So,
Cool.
Yep.
Thank you.
I was able to run it as well.
Oh yeah, that's right, and that's a result of the hackathon. So I had two people helped to basically test out the installation part of the simulator and run it, and that got improved also due to that, because well, we of course found that every laptop installation of Linux or Mac OS is different. So yeah, can always be improved. So what did we do for the draft? So last time I presented, I think it was version 21. And since then we did many editorial updates, but also actual important changes were made. So there was some discussion about basically the CA certificates request / CRTS. Basically that now got updated. So yeah, initially you could implement basically a pledge that only asks for a single CA certificate, but that we found that it's actually too limited if you consider all kinds of scenarios in the network. So ownership change, for example, or moving to a new CA certificate for the same site. So now the idea is to support multiple CA certificates in that request and response. And this is done by using an already existing type application multi-part core. It's basically a very simple way to pack into CBOR multiple certificates of any type that you wish. So this shows type 287 in example. This is an X509 certificate, but you can also in the future have other types of certificates there. There's also C509 being developed in IETF, so maybe that will come too. And another update was basically move join proxy details all to the specific join proxy draft, as Torles already mentioned. So we want to update that, I think, as soon as most of the work for this is done. So we can get started with that. Although it would be maybe good to keep Cbrewski draft also a bit open, because the drafts have such a big overlap. They work together, so they might have to be updated together as well. Okay. Next one. I don't know how much more time I have. I think I have 2 more slides of updates.
Take your time.
Yeah. Okay, that's good. Thank you. So one thing was a name change. So we have the media type for the COSE voucher. It's now updated to applications / voucher plus COSE. So using a plus and using plus COSE specifically. So that took some investigation. What is the best thing to put behind the plus? And we settled now on this actually. So hopefully it's good. Yeah, this.
So,
Yeah.
is that still being requested by ANA? Was there an early request? I mean, this is somewhere in the registry, right?
Yeah, so the request is now made in our document, basically, for the plus COSE. I'm not sure if that's already allocated by IANA in the registry, but it's now requested in this draft at least.
Well, let us know if you want to have an early allocation or something like that. I have no opinion right now whether it's beneficial or unnecessary.
Yeah, it's not really needed, it
Okay.
seems, right?
Mhm.
Because it's just only this content format. Yeah, we use typically the number, and that's still the same. So yeah, you won't see the plus COSE on the wire, at least not on the constrained network. So yeah, maybe it will go on the HTTP. But still, yeah, it works. So that's okay. Yeah, one other thing that was updated is basically the discovery details. So it got simplified a bit so that we support one method here, which is co-op discovery, and there are many other methods possible. And we decided to let alternatives be handled in a kind of unified way by doing that in the Brewski discovery draft. We still have a little bit about other discovery methods text is there. So it briefly mentioned DNS SD service names that can be used for the case of DNS SD or MDNS discovery. And also not a real change, but more like an addition for completeness was for DTLS 1.3. There is this extension record size limit that's now mentioned, like, okay, that's what you use for 1.3. It's a different one than for 1.2, so that's why it's worth mentioning. All right, I think there's one more slide with some editorial changes. So there was a kind of ongoing rebase of the text to mention the draft ANIMA RFC A366 bis instead of the actual RFC A366. So that's would be useful, I think, because yeah, there are more quite a bit of items updated in the BIS draft. So it's best to refer to that one, I think. All right, so also the appendix was extended. So appendix A was about using libraries for crypto. Now it's generalized into a software pointers appendix. So it has this crypto libraries overview, but also open source software pointers. So we can keep updating that when something changes. And there's a new appendix. So that's where some previous content got moved that was in the draft. So this was about pledge, discovery, options of onboarding, and enrollment options. So it's something we wanted to document because there's a lot that is made possible by co-op discovery. You can make very complex things and let the pledge behave in complex ways. But the idea was for constrained Brewski, well, you would typically try to avoid using all of that because it adds more round trips and doesn't help anything to reduce the byte count overall. So this is kind of kept for for people who are interested in that, for more complex discovery of different onboarding options. But the typical constrained pledge, so the new IoT device will have only one way, I think, to onboard. Maybe in the future that will be more, but to save code size, it will have one preferred way of doing things, and it just executes that. That's something I found also by prototyping all of that. So you want to make it as simple as possible with as little as possible bells and whistles and options. So that got moved out of the main text. So this concludes the updates. I think we might have one more slide saying thank you. Yeah, there is a GitHub there mentioned where issues for the draft text can be flagged as well, pull requests and those things. And yeah, some pointers for the software are also given in this presentation and in the appendix of the draft.
Thank you very much.
Good. Any questions?
No. Better than presentations in the beer working group. They were missing the Guinness.
Okay, yeah, this one has.
Please go.
For the MIME type registration, so the 8366 has voucher minus CMS plus JSON. So for JWS voucher, we have voucher minus JWS plus JSON. So wouldn't it be consistent for you to have voucher minus COSI plus CBOR?
Yeah, I think that was maybe the old name, right? So there are basically two options. So what can you stick behind the plus? So you do a CBOR because, well, it is a CBOR piece of data basically. So it's COSE, but COSE is also CBOR, so it's fine to use.
So it's redundant.
CBOR, but it's maybe better to use plus COSE, slightly better, because it gives more semantic information about what type of CBOR it is. So it's not just arbitrary CBOR, it's actually a specific COSE object, which encodes something, and that something is then the voucher that sits in front. And the original 8366 media type was actually wrongly specified. If you read all the specs, what should be behind the plus, it's basically, it should be something like plus CMS actually, because the outer type, so the outer envelope type, that's the type that should be behind the plus. So basically, if you get a basically CMS signed object, it's not JSON. So if you do plus JSON, that's totally wrong. So that was done by mistake. So we had quite some discussions on the mailing lists about that, but I think everybody in the end agreed that that was done wrong. So it should not be plus JSON if what you see is not JSON. It's basically a CMS blob.
Okay.
So
but then we also did it wrong in the JWS voucher.
Well, maybe not, because that is actually JSON, isn't it? You are used plus JSON, and then on the outer layer it is actually JSON, isn't it? So the signed thing, so that's still correct.
That's correct. Good.
Yes, let's review it.
Otherwise, we should fix it.
No, I think that's correct. Yeah. So.
Okay. Okay. Good. Thanks.
Good.
Okay. Thanks.
Coffee, beer.
All right. So I hope it's okay if I stay put, then it's easier for me to please. It says Brusky design team in half an hour, so. So it wasn't so bad. Yeah, obviously there's no linkage. All right, welcome here. So unfortunately, the entertainment value of the slides is going deeply down from this bad joke here. So Brusky discovery. So I was trying to, get on the agenda of DNS SD working group to get more expert review. That seems to be difficult. I think they're all asleep. So I'm going to skip over the background slides that I have in here for them. Just maybe a quick reminder, right? So one of the key outcomes of the document is the creation of a IANA registry where all the relevant parameters for discovery in Brusky across all the different mechanisms are carried. There are a couple of small minor fixes that I had to do, going through all of that, doing the examples and so on, but the whole principle of the registry hasn't changed. So if we go into the changes since IETF 120, so I changed the title, discovery and variations, because it's not only about the discovery of variations, but it's now about I mean, it was from the beginning about all the discovery, whether you have a variation or not. So then the overview section and the data model sections were hopefully significantly textually improved, sometimes shorter, sometimes longer, but I think the original text I had up to -03 was not very good. And so hopefully that reads a lot easier. There is no new technical content in that. That's just hopefully better written. So the new technical, so I'm not going to talk about this here, but if you review it, now is a better time than ever, so to speak, right? Because hopefully it's much less confusing. So coalesced new text for the actual discovery and selection part. There are new detailed requirements. I'm going through that in slides. For the proxies, for the Brusky pledge enhancements, and then for the DNS SD and Core LF encoding details. So also, so right, for the Brusky pledge, that was the thing where we need to figure out how to map from the IDEF ID into an instance name that can be discovered. And so I primarily enhanced here the required documentation that a vendor needs to provide. So there are two core pieces now. One is there needs to be a schema so that you do know how the DNS SD instance name is created, like, a concatenation of the certificate serial number and then the O object from the subject name. For in our examples, that's always example.com. So that's kind of the standard concatenation. The other one is the documentation that the manufacturer needs to provide if you start getting a box, and on the box there is some strange non-cryptographic serial number and product identifier. How can you map that into an IDEF ID that you're creating, right? So that basically these two pieces are concatenated together to form the serial number, or they could also be in another field, right? So on the GitHub, I have examples from, I think, 2 or 3 vendors, and they're not exactly the same. So that was the whole reason why we started saying manufacturers need to document the schema so that they can use existing certificates as much as possible for that. So the Brusky pledge right now is specified only for DNS SD. I'm not going to talk about the details here. If you think we want to have Brusky pledge discovery with GRASP or with Core LF, let us know as the authors. We can add that. So far, I was thinking that for GRASP, I'd rather revive the encoding of DNS SD in GRASP draft because that would do it. So I don't need to write something new here. And for Core LF, that's a longer discussion. There is one interesting thing, though, which we also discussed in the Brusky meetings, which is that I think we can have authentication of the name that you put into DNS SD if you derive it from a web PKI certificate. So there is right now just suggestive text that this could be done. There is no It's not written as a specification, so if you're interested in that, check it out. And if that sounds like something where we say, hey, we actually would want to specify that, that would be useful. I think the biggest benefit would be if DNS SD is not done through MDNS, where you're just announcing, but it's done through Unicast SRP protocol, which the DNS SD working group is just finishing up. Then the DNS SD SRP server could actually validate the authentication and only register the name when it knows that you are the device that's claiming to have this IDEF ID name. So that would be fairly powerful. So the redundant discovery and selection. So yeah, so I went through all the kind of implementation experience I had and wrote down the more details of the discovery and selection by the initiators. And that was pretty much around the fact that you discover more than one responder, whether it's a proxy or a registrar. How do you deal with that, right? So must support at least sequential selection. If it times out, you know, a timer for that, go to the next one. What's the minimum and maximum number of responders you need to be able to support when you discover them? So really something that we get, hopefully, a lot more base consistency of implementations into that and the justifications of it. So that's all based on, you know, having seen implementations that were really not that good. Because one of the main thing of the discovery mechanisms, of course, is to be able to easily overcome failure of proxies and registrars that we want to discover. The special considerations for proxies, right? Stateless proxies, of course, have a harder time to figure out if a registrar is gone because they're just forwarding packets, but they would need to check if any packets are ever coming back from the registrar to then select another registrar. So that is now also written up. And then also the fact that if you actually discover a better registrar, you don't want to break existing connections, right? So this is hopefully all now helping to write much better implementations of that. And yeah, I haven't seen any of this type, how to redundantly and reliably use DNS SD discovered information. So that's why I was thinking that the DNS SD working group should also be interested in that. The variation support in proxies. So that was basically rewritten to in a format where it does describe two possible likely useful implementation models. One is the direct connection mode, where for every socket that you discover of a registrar, you open your own socket and announce pretty much exactly the same what the registrar did, except with the proxy name. Best registrar selection, you're trying to be intelligent, you're trying to find the best registrar for each variation and only announce that. And then what I called the proxy in name only, which is pretty much a registrar that also announces itself as a proxy, and particularly the explanations that this does not help as a real general purpose proxy in all cases, right? So it does provide only limited redundancy, so that may not be sufficient for full deployments. And then the big problem that we ran into in our vendor implementation, when we start putting registrars in every site of a large enterprise, then we do actually get scalability issues with pretty much all the existing discovery mechanisms, the hacks around it, but that would have to go into an operational document, just a warning of, you know, limitations of scalability of the current discovery mechanisms we have in the IETF. The NSSD new details. So this is pretty much, I think, this is just for the DNS SD people. And so here there are two details, or two, I think, now very useful examples. One is from a router, which doesn't even have a normal host name. So there is kind of an example recommendation where how you would do it. You derive your host name from your MAC address, and then the examples for Brewski, cBrewski. So everything, you know, without any human ever touching that, for example. And then the other one where you are actually running different registrar applications, maybe one that you get from a vendor that does cBrewski, another one you get from a vendor that does normal Brewski. How would you deal with that case? First of all, you have a host name that some operator assigned, so you build derived names from each of the applications. Also add the PID, so if multiple are started. So hopefully these things are giving good example guidance to overcome, you know, typical problems that I've seen in implementations. So, and then finally, Core LF. So what I did there was also a lot of the details. For example, if you do normal Core LF discovery on a device itself, you don't even need to have the address in the schema of the reference, but that makes it very hard to pass on Core LF information. So now I made it mandatory. You must use an address, no DNS name, because you don't want to depend on DNS if you're using Core. Then I also changed the name from Brewski for the variation to just var, because there is just a general purpose registry in IANA. And if somebody else wants to use the scheme of encoding variations, you know, why give it a name that's Brewski specific? And I also added, you know, 5 lines so that we can also encode the priority and weight and have Core LF be as, you know, flexible in saying I'm the primary registrar, I'm the backup registrar, as we can do with it's just no sense to try to write yet another RFC for that small detail. So yeah, so hopefully, and then of course 2 examples where I ran through all the relevant cases that we know we have: registrar, proxy, Brewski. So hopefully that's all a lot more instructive now for implementers. Okay, that's it. Sorry, very a lot of stuff, but hopefully good time to start doing a good review.
It's a little bit too much. Earlier you mentioned the grasp DNS SD work, which in my memory should be something you has drafted before, right? It's
Yes.
already.
Yeah, so I think the my problem was just with the amount of work that this Brewski discovery was doing. I basically paused the work on that. So I think I would now start to do another revision with all the things I also learned from this, and then ask the working group again for adoption.
Okay, I think that would be useful. How much more work if you are going to combine the generic grasp and the ad hoc model of grasp in DNS SD?
What do you mean with ad hoc? Do you mean the DOL, the link local one, or?
You mentioned there are 2 models.
Oh yeah, no, I mean I could. So ad hoc just means I just write text here into this so that all the DNS SD features that we need for Brewski discovery are standalone in this Brewski draft. And I'm saying that could be done, but I would rather prefer that we do it through the generic DNS SD draft, right? So I was trying to explain why I haven't done ad hoc fixes like I did for Core LF and how I did for DNS SD itself, right?
Sure,
because
sure. Yeah, I mean, I would like to see you bring back the grasp DNS SD draft. Okay. But if it's not too much work, you can also add some section for the ad hoc model.
So I think that's always the duplicate work, and I think we did the same for a lot of the Brewski drafts, that they have a minimum discovery by themselves, so that they're standalone, and that was sometimes quite painful in duplicating the effort. So you know, given how we're doing it now, I'd love to avoid the duplication.
Okay. But I don't think the Pro AF is that much necessary by this time.
The what?
Pro.
Well, yeah, the core LF I think is pretty well defined now, and making it more general. I think beyond what is now in the document, I wouldn't want to do. I think so.
That's what I'm talking about.
Yeah. No, right.
No.
I mean, unless somebody comes and says here from the PRM people that they really want to have core LF for PRM, then I don't think we need anything more.
Okay, I was just wondering, so you're saying that wasn't included necessarily? Like if we define core LF, it's not that it applies to Brewski PRM, or?
Yeah, discovering of the pledge, right? So one of the problems is that in PRM, you don't only try to discover a service, but you're trying to discover a service instance. In Grasp, we're very flexible. We're just saying service is also service instance. So I mean, that's what I did in DNS SD in the draft, in the Grasp DNS SD graph. But for Core LF, I think we need to talk more with Carsten or so how this stuff could even work. because they have all these type of, when you do a query, right? What can you query for, right? So I mean, I'm not that much of an expert. I know all the questions to ask, but I'm not sure what the answers will be. So that's why I think it would be more work to use it for PRM.
Yeah. So if there are any core questions, yeah, we could easily bring that in an interim meeting of core because they have quite a lot, and there's usually space on the agenda to present something and get feedback there.
Sure.
That will be good next step. And I just wanted to add here, so I put myself in the queue just for considering core LF, that it can be used for the pledge, basically to discover a join proxy, which is just link local multicast based discovery using core LF. So that's simple. There's also the case where the proxy needs to discover a registrar. That's not necessarily the next hop, but that could be multiple hops away or somewhere in the enterprise network. And in that case, the client, the proxy who is making that discovery, is already a part of the network. So it could also be using, if the network has that, so it could be using the other core discovery method, which is basically RD, resource directory. So this is based on link format, but has basically different requests and response formats. So it works differently, or even though link format is used. So RD and link format are not exactly the same. So that's just a good thing to recap. So we might need to consider if we also want to do anything about the core resource directory. So it's similar like an SRP registrar, basically same function, except that it works differently, different protocols.
I'll check the existing text details until next week. So if we can take that offline, and I was hoping that it was covered, but we'll need to check.
Yeah. So maybe not. Yeah. Just one thing that you would need is, if you want to support resource directory, then you need also examples, I think, of how that works in that specific case. Yeah. So that means that registrar would have to need a message to register itself. So like, hi, I'm a registrar, and you can find me here, and then others can find that basically. But that's good to keep in mind. That just popped up into my mind. So okay.
Thank you. Okay, so we're finishing up the working group document section and going to new proposed work. And first one would be in the list, lightweight grasp from Sheng.
Yeah. Actually, this already been the third time we are talking about this, but for last two times, it's very quick. And I will be quick today as well. Next page, please. We had grasp for the self-management, and also we have many IoT networks which lead self-management functions and protocols to support the autonomic functions. But grasp is not an ideal choice for those IoT networks, given those nodes has very constrained resources. Grasp itself is built on TCP, which is heavy, and also the IPv4 v6, also very heavy, given the against the constrained resource. So that would giving the additional latency, control overhead, and memory consumption, all caused by the complex reliability mechanism of the TCP. For the weak network environment, TCP performs very badly. Sometimes actually TCP could run themselves down, particularly in the unstable mobile environment and the ad hoc networks. Next page. So that's why we proposed this lightweight grasp, in which we could reduce all those complexities, and in this we shorten the fixed fields change the 32 bits session ID to 16 bits. We change the objective names with indefinite length in the form of a text string to the 8 bits objective number, which we believe that's enough for the small scale IoT networks. We also introduced a UDP-based mechanism with alternative message-oriented built-in reliability mechanisms. Next page. That will help us to remove the dependency on TCP. In order to do so, we actually add acknowledgement based on the 16 bits number, most for length, carried in message. We add the timeout with retransmission mechanism. By doing this, we actually newly define 2 options and ACK message. We also set up the policy for all the unicast message must be acknowledged. Hence, they must carry a RIC-ACK option and also 0 or more ACK options. While the multicast message, most for informational, not allowed to carry the RIC-ACK or the ACK option. Next page. Basically, that's the proposed mechanism for lightweight grasp. Next page. You stop there. Yeah. Furthermore, we also discussed the possibility of other IP-independent methods. For some IoT networks, IP connections may not be supported. In order to adopt the lightweight grasp to those networks without IP, we just need a new locator option and a new protocol identifier should be selected and defined. That could, takes the lightweight grasp back together with the lower layer protocols. We actually give an example how the lightweight grasp could be transmitted over the Bluetooth. Next page, please. Yeah, we're now in the 01 version. We receive good reviews from Brian Carpenter. Most of his comments are addressed already. We add reception side duplicate detection mechanism based on the length cache. And we add a new negative acknowledgement mechanisms when the UDP checksum failed. There's still some work needed for more security issues concerning constraint nodes, and their possible solution will be considered together with the balance of their constraint resources. Basically, that's it. More reviews and comments are welcome. And the authors think this work is valuable, particularly this, use case for the IoT network is really needed such a lightweight protocol. And we think that's in the scope of the ANIMA working group. We would like to ask the working group adoption.
Zhenmin or Huawei. In fact, so we following the presentation, we also has the same this requirement about this lightweight. But my question on this work, I think that's the based on the UDP to implement some of this reliability mechanism. But in my opinion, why do we not directly use the Quick? Because Quick is UDP based, and also there's already had this the possible reliability mechanism.
That could also be too heavy. I know Quick is lightweight against the TCP, but still it's too heavy. And we actually, by our mechanism, we actually could do the message-based policies. That means we can, define which type of message or which single of message you need to the reliability services.
Okay.
I'm asking the same question and replacing Quick with CoAP because that is UDP based, lightweight in the IoT space, and would give us the reliability. Where all transaction based, I think we could put Grasp as it is, and with whatever mods we still want to do, and get the reliability from CoAP.
Yes, we received such suggestion before, but for the graph, it's also built on the UDP, and it has its own mechanisms or whatever the overhead. So that's why we don't take that as a as our fundamental
I think it would be good to try to make a comparison in terms of your own UDP versus using a CoAP encapsulation of Grasp, right?
Yeah, could do. I mean, actually, we are try to at the very beginning we try to be the design of protocol independent. Which when I say that, I mean independent to any kind of such protocols. But as I said, later we found out we need at least a locator to be able to identify the loads. That's why we take the UDP. It could be an example. We can. I mean, our motivation is to be protocol independent, then can get back combine back together to any one kind of the protocol.
I mean, one other aspect is, right, engineers always love when they hear familiar names, right? So
Yeah.
if it is, almost equivalent and good, maybe that's a deciding factor.
Okay, yeah, I also want to add there, co-op is an option, but it's great if you already know that you will have co-op on that node. So you already have the stack, so you get
Yes.
UDP reliability for free. If you don't need co-op, then you might rather not have it on in your memory. So, and I think TCP was also considered for, I know for thread networks, some problems arise with UDP because it does not have the congestion control, and TCP does that much better. But again, that requires that your mesh network is fairly stable, so that the nodes are not moving and such. So that really depends on the use case if that's suitable. Yeah.
No, that's why I said we need to compare. I think the other part was just what came up in discussion with you on the DNS SD mailing list, which is that one of the constraint network issues that we may have with Grasp is the flooding mechanism, right? That instead of the flooding, we may want to have a registration based system so that we can whatever we want to announce or what we're looking for to go through one node. Which is
No,
what
without the Grasp distribution draft goes through, we don't have flooding in Grasp.
No, we do. We do. ACP is, for example, is solely based on announcing
Okay,
the core service
yes.
through the flooding,
Okay,
right? So,
yeah.
and the flooding was brought up for other low power networks as a challenging thing. So I don't think we'll get into constrained networks well unless we have a better option.
Yeah, and I mean, actually, it has to be come down to the very specific environment. What kind of network, how bad the network environment would be to, compare the different protocols.
Yeah.
Otherwise, if we choose a protocol without those very detailed network environment, that's not generically useful.
Right. So I think we're running out of time. We also had two more proposals for new work. I think Sheng and I will figure out how we best deal with the upcoming work. For example, through asking for an interim, on all or some of these topics. So please engage on the mailing list on all of these future topics, and then we'll follow up. And oh, there is a Brewski design team meeting now. No, there is not.
No, that's your mind.
I'm so sorry. Okay, but you want to have the closing words?
Yes, thank you all for coming, and hopefully we would have an interim meeting before next meeting. Then, otherwise, see you all guys in Thailand. Yeah.
No, in Bangkok. Oh,
Bangkok.
and
Bangkok
by the
is
way,
Thailand.
the slides I didn't show, right? So for the people who are new here, go to the chair slide. We have weekly meetings on all the Brewski topics, right? So and that's where most of the Brewski related work is going on. So you're always welcome to join.
Thank you.
Good.
Do you have something for next session?
Well, I have this enterprise interim where we haven't prepared anything, so I need 2 hours to figure.